All right, we got two fractions, okay? What do we have to have when we're adding fractions? Common denominators. I got cosine, I got 1 plus sine. How do I get a common denominator? Multiply them together. Multiply them together. So we got cosine theta, or x, whatever you used. I'm multiplying them together. Okay? And then what I multiply to the bottom, I have to multiply to the top. Here I multiplied cosine, so I'm going to multiply cosine to the top of this one. And then I'm going to go back and I'm going to put what's already there. Cosine over here. Okay? And now, if Easter were here, he would say we've got to simplify it, and then we have to do what? Smush it together. All right, so I'm going to distribute. Sine times 1 is sine. Sine times sine is what? Sine squared theta. All over that mess. Can I go ahead and kind of combine steps here? I'm kind of skipping steps, which I don't typically do. What's cosine times cosine? Cosine squared. All right, so I'm going to look at this. All right, and it's over that same denominator, right? Cosine theta times 1 plus sine theta. Y'all with me? What now? Is there anything there? I've told you that when you see those squared terms, you need to immediately look at what? You need to look at your card. Now, folks, there's something that you got to recognize. I mean, it's got to jump out like a 3D movie. That right there. Sine squared theta plus cosine squared theta is what? 1. So I'm going to go ahead and I'm going to write it, substitute my 1 in there. And if you want to go from here to here, put Pythagorean identity. Over cosine theta times 1 plus sine theta. Can I what? Yes, why? Although they are not exactly alike, why can I do that? Because they're both positive numbers. And the commutative property of addition says that what's 3 plus 5? What's 5 plus 3? I changed the order of the numbers, but their sum is still the same, right? So these are the same. Sine theta plus 1, 1 plus sine theta. They can cancel out. What are we left with? 0 on top? 0, right? Why is it 1? Because sine theta plus 1 goes into itself one time, right? So it's 1 over cosine theta. And then you've got this, again, this is like a 3D movie. It needs to jump out at you because you've got to know these reciprocals. 1 over cosine theta is what? Secant. You've got to know that. There you go. How many of you had secant theta out of curiosity? Very good. Very good. Okay. Questions at all? All right, your odd answers are in the back of the book. I'm going to only call out the even answers. So I ask you to do 9, 13, 14, 16 through 18, and 22. Yes? All right, so 9's in the back, 13's in the back. 14, you should have had sine of x. Number 16 is 1. 17's in the back of the book. 18 is 1. 22 is 1 minus sine x. Questions? Woo, Lord, have mercy. Go. 22, yes, I'm going to do 22. Uh-huh. Okay. Here we go. Let's look at 13. Now, if you didn't do this work, what should you do? I'd copy these down. If you got them wrong, then I would do what? I'd fix your answers, okay? Immediately, you should always have your card right beside you, okay? I lock into secant squared x minus 1. That has got to be on my card. It's a squared term. It's a binomial. It's got to be on that card. And when I look, I go, oh, well, it is. It's tangent squared over secant squared. Did that get me anywhere? No? Didn't get me anywhere, but can I go old school division on this? Yeah? Let's go. All right, before I do that, I'm going to write it like this, okay? And now I'm going to change. What is tangent squared, y'all? Sine squared over cosine squared divided by, how can I rewrite secant squared? 1 over cosine squared. Do you see how this is a puzzle? Folks, you know that I may do the problem differently than the way somebody else would do this problem. I'm okay as long as you justify your work. I'm all right with you solving these however you see, as long as you can justify each step, okay? As long as you show your work and I can follow your work, it's good. It's all good. Now, what am I going to do at this point? Copy, change, flip. I'm going to copy down this first fraction. I'm going to change division to multiplication, and I'm going to flip. I'm multiplying by the reciprocal. Now look at that. Tell me what to do. Cancel out my cosines. What are you left with? Easy. It's really easy. Okay, 13 was so easy. And you may have done it. Did anybody do it a different way? Did you see? How'd you do it, Jansen? Oh. Okay. Did you get it right? Oh, okay. Did anybody get it correct but solve it differently? Zachariah, was that a yes or no? Okay. All right. Here we go. Pardon me? That was 13. All right, now 14. I told first block I'm going to do 14, 17, 22. How many times today? I'm going to do them 3 times. I know I'll do these 3 every class. 14. Secant x minus cosine x over tangent x. Folks, what do I always, when I see a fraction, what do I think? I say it all the time. You've heard me say it a lot. When I see fractions, what do I think? Old school, right? Something divided by the numerator divided by the denominator. Do you agree with me? So if I look at this, I immediately go, oh yeah, this is too much stuff in a fraction. So I'm going to rewrite it. Old school, numerator divided by denominator. Do you buy that? Okay? Everybody cool with that step? Now this gets me to a point where we always kind of sort of want to get these things to what? 2 trig functions. We want to get them down, work them down to get them sine and cosine if possible. Sometimes it's possible. Sometimes you can zig and you may find a different way than when you zag. Okay, if we go straight to our card, sometimes it makes it easier on us. Now, how can I rewrite secant? This ought to be immediate. 1 over cosine, good. Minus cosine over 1, right? Divided by who? How can I rewrite tangent? Sine over cosine. Some of y'all go ahead and you multiply by what here? Cosine. You go ahead and you flip it and you multiply by the reciprocal. Go ahead with your bad self. I'm not going to take a chance on me making a careless mistake, so I'm going to show every single step. Now, take it piece by piece. I got 2 fractions that are being subtracted. What do I need? Common denominator, which is going to have to be what? It's got to be cosine. If I've got cosine in 1, it's got to be cosine. Does the first denominator, first fraction change at all? Nope, it doesn't change at all. But when I multiply cosine to the bottom, of course, I've got to multiply cosine to the top. So that means cosine times cosine is going to be what? Cosine squared. Now, I'm going to multiply by my reciprocal. Are y'all cool with that? Okay? You got to follow me. What can I do? Easter was here, he would tell me. Smush them together. Because I have like denominators, so I've got 1 minus cosine squared over cosine times cosine x over sine x. Hey, what now? What now, y'all? Cross cancel the cosines. Seriously, or y'all you just don't want to say anything today? Or you don't understand? Or maybe both. Or you decided all outside that y'all are going to give me the silent treatment? That would be so cruel. Okay, here we go. What now? Look what we got. 1 minus cosine squared over sine. What now? Look at the card. Why? Because it's a 1 minus cosine squared, which is a what? It is sine squared. What are we getting ready to set this thing up to do? I'm going to cancel out a sine from the bottom, one of the sines from the top, so that my answer ends up being sine x. Right on? How many of you had sine x? Excellent. High five in the air. Yes! Proud of you. Proud of you. Even if you attempted something and you just kept going around in circles, I'm proud of you for doing that. Okay? Cool with this one? All right, and now let's go to 17. 17, we love 17. 1 over sine u. That's not it. That's 1 plus sine u. Okay, tell me what I have here. I have addition of 2 fractions, right? When I'm adding fractions, what do I have to have? Common denominators. My common denominator, though, is going to be what? The product of those 2 denominators. So I'm going to have cosine, bless you, and folks, let me tell you something. Today, I'm going to give you one more day to work on this and to get it right, get it perfect, okay? And then tomorrow we're moving on. It's related to this, but we're going to move right on through it. Here's my suggestion. Number 1, you got to do the work. If you don't do the homework, you're not going to understand how to do any of this, because it really is like working puzzles. The more puzzles you work, the better you get at working them. Here's my suggestion. A lot of you, just because you just don't like to take up the paper, you're going to work sideways, and you keep working sideways. It is very difficult for you, and especially difficult for me, to follow your work. And y'all know I do go through your work. If you get one wrong, I try to find where you went wrong. Work down. I got paper. I'll give you paper. Please work these problems down. It's a whole lot easier for you to do that. Now, going back to our algebra, because this is just algebra. What did I multiply to this first denominator? 1 plus sine u. If I multiply it to the bottom, I have to multiply it to the top. Same thing over here. I multiplied cosine u to the bottom. I have to multiply it to the top. And I'm going to go back, and I'm going to put what was already there. Now, what ends up happening to this first fraction in the numerator right here? I've got 2 binomials that are being multiplied, which means FOIL them. Folks, you got to know 1 times 1 is 1. 1 times sine is sine u. Sine u times 1 is sine u. Sine times sine is what? Sine squared over all that stuff. Plus what? What's cosine times cosine? Cosine squared over all that mess, right? Now, what else do you see? Which becomes what? 2 sine u, 1 plus 2 sine u plus sine squared u. What would Easter tell us now? Smush it together, because I'm going to have to anyway. And I want you to look at this over all that mess. Keep looking at it. The 1 came from in the step above where I was foiling. 1 times 1 is 1. Okay? Oh, so you're saying look at it closely, because what is exactly card? That's your 3D movie. What's sine squared plus cosine squared, folks? 1. I can't do anything other than what I'm doing, is to say, become familiar with this Pythagorean identity. And when you see sine squared plus cosine squared, you have to know that it's 1. Or when you see a binomial with a squared term, where do I want you to look? Look at the card. I always want you to refer to your card, but that's something that you've got to do for yourself. I'm not going to tell you every time what to do. Now look what ends up happening. Let me write that. I'm getting ready to lose it. What happens now? We're still just doing algebra. Combine the two 1s. Why? Because they're like terms. 1 plus 1 is 2. Now what? Now what? Look at your denominator. Is there something I can do to my numerator that would help me eliminate something in my denominator? How could I do that, though? Factor out a 2, which is the what? The GCF, y'all. That just sounded kind of Paula Deanish. Y'all. And what did you just set yourself up to do? Now I can cross cancel my 1 plus sine u. And then we get 2 over cosine u. I'm done, right? Nope. This is like leaving your problem as 2/4. And what would you do? Can you leave your answer as 2/4? No. How can I change that? Do you recognize that cosine is in the denominator? And when cosine's in the denominator, what does that mean? Secant. Now, some of you may just automatically make that change if you don't see it. How about writing it? Let me suggest this to you. I don't know if you would ever think to write it like that. But couldn't we write 2 over 1 times 1 over cosine? Isn't it equivalent to 2 over cosine? Okay? And then when you separate it like that, then you better recognize that 1 over cosine is what? Secant. So I've got 2 times secant, hello, which is 2 secant u. What do you think about that? How many of you got that one? Very, very good, y'all. Very good. Any questions at all? Old school. Go on and think old school. It's okay. Ain't nothing wrong with old school. Be sure that you are dividing by the quantity, not by secant, because then we have a whole order of operation issue. Okay? Tell me what we're going to change. Tiffany, what we're going to change? You made eye contact. Don't ever look at the teacher in the eye. Unless she gets right in your face. Come on, Tiffany. What am I going to do to cosine? Just put it over 1? Is that what you mean? But can I do that? Yes, very good. I can. Very good. Now, what else can I do? I'm going to divide by, how can I change secant of x? Bless you. 1 over cosine x plus what? Rock on. Hey guys, what do you see in that quantity? Like denominators, so what does that mean I can do? I can add them and make them 1 numerator over 1 denominator, can I? Is that right? Now what? She's like, don't look at me. I'm not looking at you. Cindy, what can I do now? It's called a fake pass. Did you see that? I wasn't even looking. Cindy. There we go. Good. Copy, change, flip. Here we go. Cosine of x times cosine over 1 plus sine of x. Now what? Now what, Morgan? You looked. Yes, you do. Try again. We're multiplying 2 fractions. What do I do? Atta girl. Over 1 plus sine x. What now? Oh, y'all all like you writing in your notes now. Like, I ain't looking up. She ain't calling on me. What now? Y'all are bad, ugly children. Ugly acting. Y'all like, I ain't looking at her. I'm gonna walk duck walk down on your level. Make you look at me. What do I need to do? Card. What's cosine squared? If you would answer the question, you wouldn't have to huff and puff. I don't care. Here we go. Cosine squared. Folks, at some point you got to be able to back up and see things from factoring. Okay? All I did was I changed from cosine squared to 1 minus sine squared, which is straight from your card. Okay? And then when you see 1 minus sine squared, does anybody recognize what that is? The difference of squares. How do I factor that? Good, Quentin. And you just set yourself up to be able to do what? Cross cancel. Okay? Here we go. We're done. Yes, you look at your card. Because I'm not requiring you to memorize these. That's it. It's pointless to memorize these identities. Some people do. I don't think any of us here at this school. Okay. I want you to look at this because if you look at number 3, that's a little bit different than what you've seen before. Okay? All you have to do is move that negative sign to the front and rewrite the problem negative secant x times cotangent x. It's just like it has a -1 as coefficient, okay? And then you keep whittling it down to go from 2/4 to 1/2. Simplify as far as you can get it, okay? Same thing for number 19. Number 19 is going to be extra credit. If you choose to do it, fine. If you don't, fine. Same thing happens. You've got this negative sine x, which, did I not write the problem? I didn't write the problem down. But if you look at it, I took that negative symbol and I moved it out in front of sine here because it was here in front of x. I moved it to the front, so then I had 1 minus that negative sign, and of course, minus a negative is plus a positive, right? So then we end up working with this right here. That's the line that you're going to solve. This one right here. That's a beast of a problem. Took me a page and a half. Now, keep in mind, I don't write little, and I have to give myself space in between, and I work down my page. I can't work across my page, okay? So it took me a page and a half to do that. Don't be a weenie and not try it. Try it. You guys need to be challenged. If you get it wrong, I'm not going to count it wrong. It's extra credit, okay? I'm not going to help you on that problem, so don't even ask. It's extra credit, okay? After the fact. Now, what's going to happen? This is 4th grade. You better wrap yourself around this material and figure this stuff out. I believe I'm presenting this information the way it needs to be presented to you. If you may disagree, and that's okay, you can disagree. If you don't like the way I teach it, go on YouTube and look up simplifying trig identities. I'll let you look at it just a second. Okay. But I'm not going to grade all 15 problems. I promise you I'm going to spot check this. What does that mean? That means I could check the first 5. That means I could check 2 from the front, 1 in the middle, 2 at the end. I could check 5 in the middle, could check the 5 at the end. Random. You need to do them all. Don't gamble and say, she ain't going to check that one. Yes. Any questions about what you need to do? You may work on this in class until the end of class with folks if you so choose, but the noise cannot get loud. Do you understand? Do you hear me? Okay, get on it.